my love for you people, and for the love of teaching forestry, Akash is here reporting for today. Indian Forest Community Service in charge, working under the regime, gonna become a deputy range forest officer. This is the 2019 Forestry Mains Paper Part 2. First question. Explain the role of normal series of age gradation and age class in forest management. Normal series of age gradation. It is the presence of tree of all ages from 1 year old to the rotational age in forest. A normal forest has a normal series of age gradations or age classes. Normality is practically attainable degree of perfection in a forest, which we strive to secure in all parts of the forest and to maintain it in perpetuity. Based on the age classes, we distribute the growing stock in normal forest to provide a sustained yield of nearly equal annual volumes through growth. The presence of a normal series of age gradations or age classes will add as an attribute to the normal forest. For sustained yield management, a forest should be managed such that the trees or crops are harvested at maturity, that is at the rotational age, and replaced by new tree or crops naturally or artificially, so that year after year or period after period there are mature trees or mature crop available to give the calculated sustained yield. This stipulates the establishment of normal series of age gradations or age classes. Coming to the definition of age gradation, when the trees of age occur on a separate area, they constitute a series of age gradations. This is achieved in a man-made forest. Coming to the definition of age class, when trees falling within a certain age limits occur mixed together on the same area, they form an age class. It is found in even-aged, regular or uniform natural forests. In uneven-aged, very irregular forest, there may neither age gradation nor age classes. In such cases, the sign of normality is the proper distribution of trees of all ages. Selection forests are the true examples. A forest is known to have a normal series of age gradations if it has a complete series of age gradations from seedlings to the mature trees in proper proportions. Similarly, a forest is known to have a normal age class distribution if it has a complete series of age classes in a proper proportions, which will permit equal volumes from annual or periodic fellings under the given rotation and silvicultural system. So this completes the first question. Describe the significance of working plan and working scheme in conserving biodiversity. See, the working plan enhances the conservation of forest through following means. It prescribes the management practices according to the site conditions. It gives the information about the past management and its result. Accordingly, it facilitates the future management by avoiding error in management, if any. It shows the information on the degraded lands. It helps the afforestation as well as reforestation program in correct orientation. It gives the information of regeneration status, and thus by this, the area requiring highest protection is easily determined. Working plan also gives the information about the local people and their demands. Hence, local people are effectively managed and people's cooperation is enhanced towards the conservation of forests. Information on soil, climate, slope, and site quality is useful for selection of crops for afforestation as well as conservation program. All these favorable points favors the conservation of forest ecosystem with the help of the working plan. See, working plan aims at a sustained yield, which is the main principle for forest management. Working plan gives the basic data such as physical factors of the locality, compositions of the forests, wildlife, etc. All this primary data is essential for forest management. So this completes the second question. Coming to the third question, explain the Metzger's theory of tree and its significance in volume calculation. This is also called as a girder's theory. This theory explains the variation in taper of tree, which is developed by Metzger. According to this theory, tree stem is considered as a cantilever beam of uniform size against the bending force of the wind. The wind pressure acts on the crown and is conveyed to the lower parts of the stem. Hence, base of the tree has higher pressure. The smaller the crown size, lesser will be the pressure on the tree base, and vice versa. Trees can withstand this stress by putting extra growth at base as a counteracting mechanism. This is the reason for bigger base and higher taper of trees in the open places. In case of plantation, all trees have least or uniform taper compared to trees in open. This can be proved mathematically as follows. Let force P is applied to a cantilever beam at its free end. L is the distance of a given cross section from point of application of force. D is the diameter of the beam at this point, and then the bending stress is calculated using the below formulae. That is S is equal to P into L into 32 divided by D cube pi. The force P on trees depends upon the wind pressure per unit area is the W, and the wind pressure per crown area is F. So we'll replace the P with W into F. Then the formula becomes S is equal to W into F into L into 32 divided by D cube pi. We'll take the equation for the D cube, and then the equation becomes D cube is equal to 32 into W into F into L divided by pi S. Thus the diameter is increased with lengthening of the distance from central point of the wind force. This completes the third question. Coming to the fourth question, define bridge and explain different types of bridges with neat sketches. See, we have different types of bridges. The first one is ford, second one road dam, third one Irish bridge, fourth one causeways, fifth one simple wooden bridge, sixth one cantilever bridge, seventh one suspension bridge. We'll go through each one of them. The first one, ford. Ford is used for taking the road across the dry river, which has a very little or no water for most of the year. A ford is negotiable up to water depth of 30 cm for motorcycle, 50 cm for cars, and 70 cm for trucks. In this, the riverbed is used as a carriageway. The potholes on the bed are filled up. A stream is forded at right angles as far as possible. The banks of the river cut down to provide gentle slope to vehicles. The portion of ford is marked by stakes to indicate the depth of water. Second one, road dam. It is a small dam that is constructed for crossing small shallow streams. In this, the road is at a bed level of water channel on the upstream side. Downstream side has a drop wall. The debris that is accumulated on the road surface is cleared regularly. Third one, Irish bridge. Irish bridge is paved dip surface of the road having a span of more than 7 meters. The formation of road is dropped to follow the bed of shallow water course. Cross slope of 1 in 12 inches for hill and 1 in 30 inches on flat ground is needed. It is located at all re-entrant curves and never at salient. The bed is paved with dry stones or dry stones with a cement mortar. It is cheaper to construct and no need for high-level technical knowledge. It can be constructed easily from the local materials available. Fourth one, causeways. Causeways are the structures providing dip in the road surface as it passes over the river or stream bed. Causeway is constructed under the following conditions. The first one, the depth of the water expected should be not more than 30 cm. The scour is not more than 2 meters. The fund availability is minimum. The road traffic expected is not so heavy. Coming to the fifth one, that is simple wooden bridge. This is the most common bridge in the interior forests where plenty of wood is available. The maximum span of this bridge is up to 6 meters. Abutments or the masonry pillar or timber poles which are erected in between the ends to hold the road bearers. Road bearers are the longitudinal beams that carry the load. Planks or round poles are laid side by side on the road bearer. A layer of branch wood or earth laid on this to obtain a smooth surface. Coming to the sixth one, that is cantilever bridge. Cantilever bridge is made up of two systems of counterpoised beams built out from the abutments supporting the road bearers in the middle. The beams are placed one above the other so that one end of each beam projected beyond the end of lower beam. The span gap is to be short so that it is to be connected by a single road bearer. The stability of the bridge depends upon the length of the part of the beam projecting out from the bank, counterweight, center of gravity of the counterweight, and its distance from the abutments and size of the beams and their transverse strength. Cantilevers and road bearers of similar size are used for construction because each bears the same stress. The length of the projection of beam should be 1/6 to 1/7 of the bridge span. Abutments are constructed at a height so that the superstructure is kept at above flood level. It is very difficult and cumbersome to construct besides huge wastage of materials. In addition to this, high-level technical knowledge is required for construction. Seventh one, suspension bridge. Bridge of this type is constructed across the large openings which do not permit the erection of intermediate piers due to swift water or any other reasons. This consists of a roadways that is suspended by cables passing over the top of the piers. These piers are well anchored on the either bank deeply. The roadway is suspended from the cables by means of wire ropes, slings, or hanging rods. The main cable is the chains or wire ropes which holds the transom. They are taken over the towers or piers. Tower or piers are anchored, preferably of buried anchorage. A transom is the horizontal beam which is suspended from the main cables by means of suspender. Suspenders are the wire ropes which are used to suspend the transom from the main cables. So this completes the fourth question. Coming to the fifth question, describe the procedure for estimating the volume of standing and felled tree. See, we have many methods in determining the volume of standing trees. The first one, ocular estimate. Second one, partly ocular and partly by measurement. Third one, direct measurement. Fourth one, indirect measurement. The first one, ocular measurement. In this, the forester can make estimate of volume of standing trees by his experience and knowledge. Here, result varies with the different workers for the same tree. Second one, partly ocular and partly by measurement. In this, the diameter and height of the some trees are measured. From this, volume of tree is assessed with consideration of taper. Then the estimator determines the volume of remaining trees by comparison. This method requires experience and the result suffers all defects as in the ocular estimate of wood volume. Third one, direct measurement. The volume is determined from the diameter and height is measured. In this, diameter is measured at different heights manually. Hence, it is the time-consuming and tiring procedure. This is not useful for a large number of trees. Fourth one, indirect measurement. The use of instrument avoids the climbing of trees for height measurement. The instruments includes are Spiegel reloscope, telireloscope, Wheeler pentaprism, caliper, and bar and strand dendrometer. Besides that, certain instrument facilitates the determination of diameter even at a different height. Using the height and diameter value, the volume of standing tree is obtained. Volume of felled trees. Volume of felled trees. Volume of felled trees includes volume of stem wood and branch wood. In some cases, it includes the root volume also, if it is economical. First, the tree is cut into logs according to the taper. The length of the log depends on the taper, utility of the wood, and the transport facility available. Generally, all logs are of uniformly 3 meter in length except the top end log that may be up to 4.5 meter. But if the end section is more than 1.5 meter in length, it is left as a separate log. This completes the fifth question.